Hi. Now, in our previous chapters, we have just looked into the random variable. We have studied about what is probability, what is random variable, and all those things. Now, the mathematical expectation is a part of probability, wherein we shall be seeing the first one. What does mathematical expectation means? Now, when you are doing an averaging of all the random variables, we should know the different aspects of random variable. When we say random variable is given as x, capital X, whereas the elements which belong to the random variable are written with that of the small x, or x say as x1, x2, and so on. Okay. Now the averaging process when applied to the random variable is called as expectation, and it is denoted by E of x. E is for the expectation and x is for the random variable. Now for this we have a study for the case of discrete as well as for the case of continuous. Now when we are considering x as a random variable with if we consider x as a random variable with the probability p of x, okay, or this can be written as probability of x is equal to xi. Now this x of I will take all the values of I, taking from 1, 2, 3, 4 and so on till n, where over here we are saying that capital X is nothing but the discrete random variable, right? And it is having a finite values, that is from xi is equal to x1, x2, x3 so on till x of n. Now the expectation of this random variable can be written as expected value of x is equal to m, okay, or where m is nothing but it is read as mean, or we can also write as mu, where it says that summation of I equal to 1 to n x of I probability of x of I. This is for the case of discrete function. Okay. Now similarly for the case of continuous, we can write as what in when we are saying continuous, it is defined from limits. What are the limits? The limits are defined from minus infinity to that of the plus infinity. Okay, the same one, that is E of x, that is expected value is equal to m mean, is defined from the integration minus infinity to plus infinity x into fx of x dx, where this x indicates small x, x indicates that it takes all the values, and f of x is nothing but probability density function, right? Now similar manner we can study for the case of when x is random variable, discrete random variable with probability distribution function, okay, PDF, then the expected value or mean can also be written as E of x is equal to m, which is equal to summation I equal to 1 to n x of I p of x of I. Now in the previous one we have just talked about the random variable x with respect to the discrete as well as for continuous. Now when we are considering a function, the function is a real value function given as g, then the same thing, that is expected value is written as expected value of x is equal to m, which is equal to summation from I equal to 1 to n g of x of I. Now over here this g of x of I is nothing but it is a real function into probability of x of I. Now this we are saying for the discrete random variable. Similarly the same can be written for the case of continuous. Now for the case of continuous random variable, x is given as, in place of summation it will directly change into that of integration, and the limits will change as from minus infinity to plus infinity. So we get the equation as E of x is equal to m over the limits minus infinity to plus infinity, okay, function g of x into fx of x dx, right? This is for the case of real value function.